Hey everybody, welcome to 3.4. Today, this is the last section in chapter 3, and we'll be discussing how to use similar triangles. Our learning target is I can ID similar triangles and use indirect measurement to find missing measures. All right, here's our key idea, and something that's maybe a little bit new, but we're going to use our rule of thumb for triangles. That our three angles sum or add up to 180 degrees. Okay, so it says when two angles in one triangle are congruent to two angles in another triangle, the third angles are also congruent and the triangles are similar. Okay. Remember, the meaning similar is same shape, not necessarily the same size. A lot of the times, well, let's just look at a few examples, and I think that'll explain that. So it says here, triangle ABC is similar to DEF, ABC, DEF. And remember, this little squiggly means that they are, the two triangles are similar. Okay. So for example 1, it says, tell whether the triangles are similar and explain. Right here we've got in the first triangle 50 degrees, 75 degrees, and X. And in the second one, we've got 50 degrees, 75 degrees, and Y. So if I'm thinking about an equation to write for this triangle, I would say 75 plus 50 plus X. We know that that needs to equal 180 degrees. Oops, sorry, not 1800, 180 degrees, because that is one of our rules about triangles, is the three angles added together need to add up to 180. So if I could simplify a little bit here, 75 plus 50 would give me, 125? Plus X equals 180. Okay, so then I would solve by subtracting 125 on each side, and I would come up with X equals, and what is 180 minus 125? That would be 55. So let's just double check. Is 55 plus 75 plus 50, does that give me 180? And yes, it does. So this angle would be 55. How about this? Well, if you look at our equation, it would be the same. This angle plus this angle plus Y needs to equal 180. It's the exact same. Simplify, and then isolate my variable, and Y would equal 55, right? So these two triangles have two pairs of congruent angles. 75 are similar, 50 are similar, so these ones need to be the same. Let's try for letter B, where it might not be so obvious. Here it was pretty obvious because there was a 50 and a 50, a 75 and a 75. It might not be quite as obvious in letter B. I've got 54 plus 63 plus X equals 180. All right, 54 plus 63 would give me 117. Plus X equals 180. To solve, I would subtract 117 on both sides, and X would be equal to 180 minus 117. I would total 63. So X would equal 63. So I have 63, 63, and 54. Well, look at here. If I have 63 and 63 as these two bottom, or these two side angles, that would match up with this bottom triangle. What's the only value that's left for Y to equal 180? Well, You could write it out, but I'm guessing a bunch of you are already seeing the writing on the wall. 63 plus 63 plus y equals 180. If I add my like terms, I'll come up with 126 plus y equals 180. And then I'll subtract 126 from both sides. So 180 minus that 126 gives me a total of 54. And look at here, matches up with that other one. So tell whether these are similar. Yes, they're similar. The triangles have two pairs of congruent angles. So the third angles are also congruent. Yes, the triangles are similar. Very similar for letter C. Again, we are going to use 90 instead now. So we've got 90 plus 42 plus x equals 180. All right, 90 and 42 would give us 132 plus x equals 180. Okay, 132 plus what number would give us 180? Okay, in other words, subtract 132 from each side of our equation. And 180 minus 132 would give us 48. So our three angles would be 90, 42, and 48. Let's look at our other triangle. We've got 90 and 38 and y. And you might already see, okay, 38 doesn't match up with either of these angles, so it's already going to be a no, but let's just double check. 90 plus 38 plus y is equal to 180 degrees. Adding my like terms, 90 and 38 will give me 128 plus y equals 180. And subtract that on each side, and y would equal 180 minus 128 would be a total of 52. Okay, sorry about that. I'm just going to erase that email coming up here. So my angle measures on this triangle would be 52, 38, 90, whereas this one was 90, 42, and 48. So they are close to being similar, but their angle measures are not congruent. They do not have two pairs of congruent angles, so they are not similar. All right, go ahead and pause the video now to try 1 and 2 on your own and see how that goes. All right, for number 1, hopefully you arrived at no. They are not similar. They do not have the same angle measures. And for number 2, yes, the triangles have the same angle measures, 90, 66, and 24. All right, a little bit of vocab, and then example 2 will finish it up for us today. It says an indirect measurement uses similar figures to find a missing measure when it is difficult to find directly. All right, so here's a case of that, of when we can use indirect measurement. It says you plan to cross a river. All right, it might be a little bit tricky to see, but here you are. Okay, you plan to cross the river and you want to know how far it is to the other side. So we're starting here and we want to cross the river and we want to know how far it is. That's why you'll see it's labeled with an X. Okay, that distance is an X. You take measurements on your side of the river. So here's ABC. We're taking some measurements on here to be able to see, okay, how far is it actually across? All right. So explain why triangle ABC and DEC are similar. And then letter B says, what is the distance? Okay. Well, remember, to be similar, we need to have congruent angles. Right? So let's look here. I've got angle B and angle E. Angle B and angle E are both 90 degrees, right? Those are both 90 degrees in this triangle versus that triangle. And now I only need to know what one more angle measure is. Because if I know that these two are congruent, if I can say that two more angle measurements are congruent, I know the third has to be. Well, if you look at this diagram, angle C right here on both of these triangles are vertical angles. Okay, this one in the red, let me use a different color compared to this orange one right here. Oops, my color didn't come through. These two angles are vertical to each other. And we know that vertical angles are congruent. So we can say that ACB, angle ACB, and angle DCE are vertical angles. And vertical angles are congruent, right? So we know that these two angles are the same and these two angles are the same. So when two angles are the same in a triangle, the third angles must also be the same because there's only 180 degrees. So they'd have the exact same amount left. All right. So that's how we can explain why we know they're similar. Now for letter B, it asks us to find the distance across the river. Okay, well, we know that they're the same shape. Now we just need to make sure, the other part of being similar is to make sure that they are proportionate to each other. So I'm going to write down first, check proportion. Proportionality. Make sure that these let's set up a proportion so that we can figure out this distance. Okay, so how can I do that? Well, I can say that the ratios of the corresponding side lengths in the similar triangles are equal. So let's see if we can do that. This missing side here, x, what could I say is the matching side on this triangle? All right, imagine that I took this triangle, the one that I'm crossing the river, and I turned it this way. This side would now become this same side of my bigger triangle. So x is compared to 60. And that should equal, what are two other sides that I can compare of my triangles? Well, I know the base of of my smaller triangle is 40 compared to the base of my bigger triangle when I rotate it, right, to keep that same shape, is 50 feet. All right, here are 3 out of the 4 missing values I can solve using the cross products property to find the missing value. X times 50 is 50x equals 6 times 4 is 24, and then I've got a couple zeros. Right, now let's solve. I just need to divide each side by 50, and 2400 divided by 50 would give me 48. And I'm talking about feet here. All right, so does that make sense that this triangle is smaller, but it's still proportionate to this one? We figured out that the triangles are similar. They've got congruent angles. So our length or our base of this triangle is smaller than this one, so we would expect also that our length, the distance across the river, is smaller than this distance of the similar triangle. Right? So that is using indirect measurement. Why don't you pause the video now to try on your own for number 3. It says if the distance from vertex A to vertex B is 55, So vertex A to vertex B is 55. So you're just changing that to 55. What's the distance across the river? All right, so we would just, our new equation would be x over 55 equals 40 over 50. Cross multiplying, we get 55 times 40. So we would get 50x equals 55 times 40 is 2200. And then divide by 50 on both sides. You'd arrive at 44 feet. All right. Let me know if you have questions on that one. Indirect measurement can be a little bit tricky at first, so I'd be glad to help. And that does it for the fourth and final lesson in Chapter 3 of using similar triangles. I will see you guys next time.